Thanks for having me return to the EMEA webinar series. And I know that this is a interesting topic that was a big theme at the ICANN meeting in Sevilla earlier in the month. So I'm hoping to share this in a way that is both relatable, but takes something that is complex and presents it in a way that might help inform some conversations that will likely be continuing at other events in the community, whether between now and our meeting coming up in Bali later this year. So a quick note about me, I've been working at ICANN for over 20 years now, and I've worked across a variety of functions from our registry function, security team, and global stakeholder engagement team. And I've also spoken to this audience periodically on various topics. So what I wanted to do was take something that is frequently discussed in the community and present it in a relatable way to explain how AI models work with internet identifiers. And to do this, I did a very unscientific test of comparing two popular models, asking very similar or the same prompts, and repeating that about 2 months apart. Before we dive into the prompts that I use, I'm going to share a little bit about how technology changes a constant in our work at ICANN, and we're regularly asked how new technology impacts the identifier space. And so this graphic has an eye-catching headline, but the point is that we've seen these shifts occur as the internet identifier space has grown, from the mobile internet being developed in the late 1990s, early 2000s. This allowed for new access patterns, registrant behavior in accessing the internet on mobile devices. Then with the addition of DNS security extensions, which added a layer of authentication and validation to the original unsecure DNS protocol. This happened between 2005 and the signing of the root zone in 2010. Then we saw in early 2010s, Internet of Things became popular, and that led to machine-generated DNS queries and device identifiers. And then this is also the time when the number of devices using the DNS surpassed human users. And so operators saw massive distributed attacks using hijacking Internet of Things enabled devices. Then after 2013, there was the development of DNS encryption, DNS privacy protocols that led to other changes in how users access the DNS. In the ICANN space, in the early 2020s, we saw a return of conversations around alternate namespaces. And then blockchains were a big topic. Now we're starting to see artificial intelligence and its impact on the DNS become a significant topic as well. Want to point your attention to a blog post that was written by Matt Larson in our Office of the Chief Technology Officer at ICANN. This was published in March. There's a link here, but you can also find this on the ICANN website. And the blog clearly explains how artificial intelligence is the latest in a line of technology impacts on the DNS and on ICANN's work, and that AI doesn't change ICANN's core mission or the fundamental architecture of the domain name system, but it's with other technology shifts, there are implications for the internet ecosystem that ICANN operates in. And I think the blog helped inform discussions at the ICANN 86 meeting, and is one that I would encourage either participants here or others in the community to refer back to that blog, because it is, I think, a very helpful document of framing the conversation. So with this next slide, I have a few terms I want to share. I'm not going to spend a lot of time talking about these things of what is a LLM, how does generative AI work. It creates text, images, code, create audio and video files. And these generative AI tools might use something called a model context protocol to serve as a bridge between agents and things like Google Docs or a file on your desktop or some other system that connects these models to tools that you might use. Now, some considerations that we want to recognize is that large language models typically aren't networked applications unless they use something like a tool for web search or web fetch. And they don't use the DNS in the way that a browser or a mail server does. The networking happens around them, not within them. Something also to consider is that the way that the models use data depends heavily on the knowledge that the model has absorbed about the identifier system. For example, Claude knows the structure and the delegation hierarchy of domain names. They understand DNSSEC concepts, the allocation structure of IP addresses, and how the regional internet registry system works. The model understands routing registries and peering contexts, but the information is static, and this creates a gap. So I have it here on the slide that for Claude Sonnet 4.6, which is one of the models that I used in this test, the information in the model was cut off as of August of 2025. And there's a lot of new domain names or protocols that might have been developed in the nearly year that's occurred since then. And so this leaves a lot of information that the model doesn't know without doing a web search. Something else to keep in mind is that some of these models use agents that might make autonomous calls or interact with APIs or domain names, and that's in a way that raises questions for this audience to think about how it might influence domain name system abuse, or how identifiers are used, or how accountable these models might be. And I don't have answers to those questions, but it's something that this audience and others might need to consider. So today's approach looks at two popular AI models and explores how they handle internet identifiers differently. I tested first the 30th of April using the free version of Claude Sonnet 4.6 and using Google Gemini. Since then, Gemini has updated itself with its 3.5 Flash model that was released in mid-May. So then I reran the test again to see how the answers of the responses might have changed. And not surprisingly, they did change. The responses were not significantly different, but substantially unique enough that it's just worth recognizing that depending on when you ask the questions of an AI model, the responses you receive can vary. And this depends also on the model that you're using and when and where you're asking. So for prompt one, I asked both of the models how they interact with and use the internet's unique identifiers to respond to queries. And first for Claude, the identifiers themselves are consumed and partially absorbed into the model's weights. And so the Claude knows that .de is for Germany and that the IP address blocks that belong to the private address space. It knows what those are. It also knows that IANA.org is authoritative for protocol parameters. And so these are all facts that were built into the model. And Claude Sonnet works with Internet's unique identifier system in distinct ways depending on the mode of its operation. And so it might fetch vast amounts of web content, and it can scroll through content from domains that are registered across TLD registries. But when it does this initially, it doesn't make DNS queries. It doesn't have active IP connections that are initiated by the model. And it is what's called a stateless mathematical function. So just the big point here is that Claude's knowledge of the DNS space it's limited, and it might miss a lot of new domains and identifiers that could have been registered or added in the time since August, or since the model was frozen from cutoff. Because Claude itself doesn't hold a DNS resolver, it doesn't query registries directly, and it doesn't have a persistent network identity. So it's a language model that produces text, and it might inference or request identifiers depending on if a web search or a web query is used. And so this makes Claude a consumer and an indirect invoker of the identifier system rather than a participant in how it's operated or maintained. This is a graphic that shows how Claude might receive information in a query. So if you're in a browser, you first look up Claude.ai. .ai is Anguia's country code top-level domain. Anthropic chose this for its semantic association to artificial intelligence. Then your DNS resolver or your ISP's resolver queries the DNS and returns a response using IP addresses, using information through the RAR system, and your query will trigger a web search. And so this, I think, is also helpful to understand that every single query you put into Claude depends on a correct, stable coordinating function of the identifier systems. And even though the model itself is unaware of the domains that might be used, it's using the DNS. And Anthropic has specifically chosen the .ccTLD as the way it's communicating this information, and it's done this in a way that connects the user with it's how they're using this. Here's a comparison of both Claude and Gemini as an image, and they show how they're using the DNS and the identifier system. Now, Gemini's response was different than Claude's because Gemini uses something called grounding with search. And when Gemini interacts and uses the DNS, they're using real-time inference and training, and they also operate within the backend system that Google maintains. So they'll leverage Google's infrastructure for responding to queries, and this is done differently than the way that Anthropic has built Claude. So with the second prompt, I asked, when I'm asking queries of Claude, I know it uses the .ai ccTLD in the background. So how does Claude use unique identifiers to respond to answers in a conversation? And then I asked a slightly different question of Google to ask specifically what were the domains that it uses in responding to queries, and how does Google use its own content delivery network and infrastructure, and what its training data cutoff might be, and when its identifier knowledge might become stale. And then I asked what happens to both of these models when new top-level domains are delegated, and how regularly do the models check the domain name system to confirm the information in response to queries. So Claude's response was different than what came back from Google Gemini. Claude doesn't know when new top-level domains are delegated. Again, this is the training data cutoff. So any top-level domains that were delegated after August 2025, unless it's doing a web search or a web fetch, it's not going to have knowledge of those new domains that might have been added. And then how regularly does it check the DNS to verify things? Because Claude doesn't do this, without that web search involved, it won't verify information. With Gemini, because it's using Google search embedded in the model, it does query the DNS in an on-demand way. So key takeaways for this audience is that the information that's in an AI model is static without that ability to access the domain name system. And the information it contains may involve errors. It might provide different responses at different times depending on when you ask. And unless that AI model is regularly actively checking the domain name system through a web search or a web tool, it's not going to recognize when new domains are added, whether there's new protocols added to the DNS or some other change that might have been made. Now, I have some questions that I've seeded with this talk, depending on if the members of the audience are from registries or registrars. Have they noticed any queries that have been increasing in their servers due to AI model use? And for internet service provider community members, are you seeing agentic AI queries as a new type of user, or how do you see that in the traffic that you're seeing in your networks? So I'll pause here. And Gabby, does anyone have any questions so far? I know I've provided a lot of time, and hopefully there's sufficient time to cover things that people might ask.
Thank you, Patrick, for this really interesting presentation. We have a question, it's a clarifying question from Riyadh Zara. Do we mean by unique identifiers the IP addresses, protocols, and AS numbers, or something else, please?
Yeah, all of those things, anything that is involved in the IANA system, which could be TLDs, IP addresses, protocols, etc.
Thank you. And then you just have a comment. Thank you for the good presentation.
I will say, so this was a bit new for me, and I am trying to share things that were both technical in a non-technical way, hopefully interesting, and again, point people back to the Octo blog from March of this year, because it's still all relevant information.
Thank you for clarifying that. We have another question from Shidakwa. My question is, how do you think these models will develop, especially when it comes to reducing errors? What is the biggest challenge in your view?
They're constantly changing and evolving, and just seeing how the models differed from when I asked the first set of queries at the end of April to asking the same things again just 6 weeks later. So it shows that these are continuing to take in new information all the time and respond in interesting and relevant ways. Yeah, we'll see how they continue to grow and evolve.
Thank you. Eberhard Liste is asking, how can we recognize these queries with a view of blocking them?
So as an operator, I think that's something that you and others need to factor into your operations. So I don't have an answer for that, but yeah.
Thank you. We have a question from Elliot Hollerton Hill. Is there any standardization being discussed, written within the IETF regarding AI usage of the DNS?
I don't know. I think the next IETF meeting is coming up next month, and I would assume it would probably be one of those topics or sessions there. I suspect this will continue to be an active theme of our meetings at ICANN later this year and into the next. I'm curious to see and hear where it goes.
Thank you. We have a question from Alexander Meyerhofer. Estimating agents are or will be soon used to create suspicious, malicious registrations. The question is, do we believe that this is covered by the current anti-abuse regime?
I'm not sure. But I know there were sessions in Sevilla where AI and DNS abuse were covered, and expect this will continue to be an active area of conversation, both in our meetings and in other community events in the next few months.
Thank you. We have a question from Mikhail Anisimov. Does ICANN consider any option to use a custom AI model trained especially on DNS data for any domain-related purposes, like DNS abuse mitigation? It might be done in partnership with any existing LLM providers or separately.
That is an interesting question for my Octo colleagues. I don't know what their plans are with using LLMs with Domain Metrica or other tools that they have, but I think we'll need to refer that to them.
Yeah, we will actually have Sean Lard speaking about, I think, Domain Metrica in the autumn, so we can ask him about that. Thank you, Michael. I have a question. Like you said, the tools don't understand when, for instance, a new domain name is created. What can we do about that? Should we knock on Google's door and say, hello, do something about it? Do you know anything we can do about it, like concretely? No.
Yeah.
Okay, my second question is there any big surprise for you? Was there anything that really surprised you when you did this?
So the couple things that surprised me, that the answers that both the models provided were changed as much as they did. The overall theme and the way that it responds, both Claude and Google Gemini, is essentially the same, but the thoroughness, I think, changed in June when I did this last week. So I think that's something to keep in mind, is that these things do change. The way that the models respond changes. And if you're expecting it to not change, then don't, because they will respond differently depending on what you ask and when you ask.
Thank you. So thank you so much, Patrick. I just wanted to also say two things. First of all, Patrick's presentation is already posted, and the recording will be posted shortly after the end of this webinar on the page that I just posted in the chat room. But the second thing is, as I mentioned, this is the last webinar for this season. We will be back at the end of August. Thank you, Patrick, for closing this season with such an interesting talk. And I hope to see you back again. And thank you, everyone who joined. Thank you for your great questions, and see you end of again. Thank you. Bye-bye.